Hey guys, today I want to show you how we can use Unity's input system to rebind controls for our game. This is pretty robust and it has a lot of functionality, and I will walk you through every step so that we're all on the same page, including how to remap controls for multiple control schemes. In my case, I'm doing keyboard and gamepad, and I will show you how we can display text for the rebindings as well as icons. Ready? Let's go. So here's my scene, and I really have nothing going on except for a simple menu with some settings that I can go into, which are completely blank when I go into them. So we'll build the Rebinding UI together. But if you want to know how to build a menu like this one, especially if you want to be able to scroll through the buttons with your keyboard or gamepad and not just click with your mouse, then I have a tutorial right here that will show you how to do that. I've separated the keyboard and gamepad controls because I checked out a few other games and that's how most of them handle it. So we'll build this like a commercial game does. So to start, we obviously want to make sure we've installed the input system from the package manager. But just as importantly, we want to open up the samples dropdown here and import the Rebinding UI sample. Unity has already put together a set of scripts and prefabs to make this really easy for us. Their script is hundreds of lines long and does the job really well. So to save time, we'll use theirs and add functionality on top of it to make it as awesome as possible. So first, let me show you how we set up our controls. So we would right click and create a new input action. I already have one called controls. Now, normally I like to generate a C# class for my controls, but in order to rebind controls, we're going to have to do this a little bit differently. So leave that unchecked, and instead let's click Edit Asset and dock it over here. So first you create your action map. You might use this to separate things like gameplay controls versus UI controls or minigame controls, stuff like that. For this, I've just got an in-game action map. Next, you want to set up your control schemes. I already have my two here, gamepad and keyboard. But when you create one, you just want to make sure you type in the name, click the plus button here, and then select whether you want it to be optional or required. When we're done, let's just make sure that we set this back to all control schemes so that we can set up both sets of controls at the same time. So now in our actions section, I've created all the actions I needed for this little demo scene. So for this, I have 4 button actions: dash, attack, jump, and menu open close. Within each of them, I've assigned both a keyboard and a gamepad binding. You can just press the listen button to find them easily and be sure to assign them their proper control scheme over here. And finally, I have a pass-through with a vector2 control type. A vector2 control type will allow you to make up, down, left, right composites. I've made 4 of those, one for WASD, one for the arrow keys, one for the analog on my gamepad, and one for the D-pad on my gamepad. Depending on what you want, you might want to change the mode here, especially for things like analog sticks that aren't just 0 or 1, they have in-between states. With digital normalized, I'm using my analog stick right now, and you can see that he snaps to full movement or no movement at all, and digital works the same. They both behave the same, it's just that the returned result of digital normalized will be normalized and digital won't be. Analog, on the other hand, you can see I can control his speed depending on how much I'm moving the analog stick. So for mine, I'm going to switch this back to digital normalized. Now let me show you my preferred method of actually detecting these inputs with code. I've created a user input script and attached it to my input manager object here. And before we open it, notice that I've added a player input script here as well. This comes with the input system, and essentially if you want to do key rebinding or make use of gamepad rumble or any kind of advanced stuff with your input, you're going to want to use this. It just makes it all so much easier to do. So you can plug in your controls here. We can leave our default control scheme to any and our default map to in-game. Now for the user input, first off, I made it a singleton. This makes it easier to reference and we'll only ever have one of those, so it's a perfect use case for a singleton. Now what you want is going to depend on your controls, obviously, but for me, these are the inputs I want to detect based on the mechanics my player has. I have a reference to the player input that I just showed you, and I've set up input actions for each of the actions in our controls. To set those up, we grab them from the actions within the player input script, and it utilizes strings, so make sure you get your spellings and capitals correct here. Then in our update, we can actually update all these public variables from up here. The move input, we can just read value and return a vector2. And the rest we can use either the .wasPressed this frame, .isPressed, or .wasReleased this frame function, depending on what you want to return. Now this is a nice solid script to grab your input from. To call these, for example, I'll just show you my movement. I'm referencing userinput.instance.moveInput. You don't need to do getComponent or anything like that because this is a singleton. And this value will get read with either your WASD keys, your arrow keys, or your analog stick, or your D-pad on your gamepad, which is awesome. Okay, so we're on the same page now. We have our controls set up. Let's set up the key rebinding system now. So in samples, input system 1.5 or whatever version you're using, Rebinding UI, take this prefab and I'll drag it into my keyboard canvas first. And before we change anything, I want 6 of these lined up nicely. 2 for movement, WASD and arrow keys, 1 for dash, attack, jump, and menu open and close. Let's make these child objects of a rebindings object, and we'll use the grid layout group with a cell size of 100 on the X and 50 on the Y. And let's scale these up to 1.75. That's looking pretty good. I also want a reset all button above my back button here. So I'll add a Text Mesh Pro button and we'll leave that as is for now. How many rebindings you want is up to you. If you go to the Rebind Action UI script here and assign your input action and click binding, you can see all your options. We can do WASD all at once, or we could separate them individually, whatever you want. I will keep mine together here. And right off the bat, there's already so many things I want to change about this. The first of which is to upgrade this to Text Mesh Pro. I don't like the legacy text, and I have no idea why they built this using that. Now, you won't be able to just reference Text Mesh Pro in here. You're going to have to go to this assembly definition asset and add unity.textmeshpro over here. Now we want to replace these 3 text fields in the code with Text Mesh Pro instead. If you highlight this and click F12, it'll take you down to our serialized fields, and let's replace these text fields with Text Mesh Pro as well. So here, here, and here, we'll replace text with tmpro.textmeshpro.u GUI. Now that the code is done, let's actually change this prefab and update the components. So the action name text should be Text Mesh Pro. In the trigger rebind button, the text should be updated to Text Mesh Pro as well. And in the reset to default button, this never changes, but let's update it to Text Mesh Pro as well to keep things consistent. Okay, awesome. So we're done with this prefab. So for our first button here, let's make sure we've assigned everything. We've got our action plugged in. I'm changing the WASD binding. And for the action label, plug in our action name text. For the binding text, the action binding text. Now these last 2 we need to create. So let's create a new panel and we'll call it wait for input panel. Throw it at the bottom so it's drawn over top of everything else. And inside of it, create a Text Mesh Pro called wait for input text and make sure the panel is inactive because it'll be activated with code when it's needed. And so finally, let's plug in the wait for input panel here and the wait for input text here. So let's go ahead and test this. And we're going to get an error here. That's because it won't let you rebind keys that are currently enabled. So let's go back to our Rebind Action UI script and let's find the perform interactive rebind function. And after the cleanup at the beginning, let's disable our action. And then we'll enable them again in the onCancel operation as well as the onComplete operation. So no matter what, our controls get re-enabled as soon as we're done with this function. Let's go ahead and test this again. And now it should actually be working. I can remap this to these keys. And now I'm moving with those new keys. So real quick, let's plug in everything for all the rest of the keyboard keys. And you can see that we've got a few different display options here. I'll include the documentation in the description for anyone who's interested. Now, there are a lot of potential issues here. First of all, once I click this to remap it, there's no way to cancel out of this. Let's fix that first. Back in our script, within the perform interactive rebind function, we can add a dot with canceling through, and you can actually see there's all kinds of options that you can make use of here, but we want a way to call this dot on cancel function. And we can do that by adding dot with canceling through. And for me, I'm going to do that with the escape key on the keyboard. And actually, while we're here, you can exclude certain types of controls in the same spot. The way I set up my controls, this isn't really necessary for me, but if you set it up differently without assigning control schemes, you might, for example, accidentally click your mouse button, and then that will be your new key rebinding, which you don't want. So if that's the case for you, you can use dot with controls excluding, and you can do mouse or just specific clicks on the mouse, whatever you need. But again, if you set yours up like mine, this shouldn't be necessary for you, at least not for different devices. Okay. Our next problem, you can see if I go to rebind my WASD, I can just press up, 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 and it accepts all of them. We obviously don't want that, so let's add the option to ignore duplicates. So down here, let's create a function called check for duplicate bindings. And we'll add an input action, binding index, and bool argument, and let's default that to false. So first, we'll get the new binding to check for the duplicate. We'll iterate over all the bindings in the action map. And if the current binding is the same as the new binding, we'll skip it. And if the effective path of the current binding matches the effective path of the new binding, then a duplicate binding has been found and we'll log a message and return true. Next, if all composite parts is marked as true, then we'll iterate over all the bindings before the current binding to check for duplicate composite bindings. And if the effective path of the current matches the effective path of the new binding, then again we have found a duplicate and we'll log a message and return true. And if no duplicates were found, simply return false. Now up here, let's check for duplicates before updating our binding display. So if we have a duplicate binding, we'll remove that binding override. We'll call the cleanup function and call this function again before returning so we can try a different key and then return. So let's test this. Now, if I press W more than once, we get that message and I'm forced to pick another key. And if I try to use W down here, it won't let you do that either. Now, we aren't out of the woods yet, but before we continue, let's make sure we have all these reset buttons hooked up correctly. They should all be calling the reset to default function from the parent object's Rebind action UI script as well. Now, let's say I change my dash to a 1 and my attack to a Z, which is what my dash was before. And now if I reset my dash, you can see that we did manage to get a duplicate in there, which is no good. So let's fix that. So in the reset to default function, we're going to comment all of this out, and you can do Control K and then Control C to comment it all out at once. Instead, we're going to create a reset binding function. We'll cache a reference to the current binding, remove the current binding, and then create a for each loop to check all the actions in the map. So if the other action is equal to the action, meaning if this is the original action, then we'll just skip it and continue. Otherwise, we'll check all bindings for duplicates within the action. So if the override path is equal to the new bindings path, then what we'll do is swap the bindings. So let's call this here, and I'll show you what I mean. So if I do the same thing as before, I'll change my dash to a 1 and my attack to a Z. Now let's reset the dash. You'll see that the two have simply swapped places instead of allowing the duplication to happen. All right, next, maybe you don't want this name to derive directly from your action, but you'd like to give it a name yourself. So let's add in the option for that. So the appearance of this script in the inspector is controlled by this editor script here. That's how they get it to look nice with all these little headings here and stuff. So let's expand what they already gave us. So before we go into the editor script, let's go into the Rebind action UI script one more time and add 2 fields. We want a public bool called override action label and a private serialized field of type string called action label string. So you'll notice right away that even though we made those public and serialized, they aren't showing up in our inspector here. That's because we now need to change the editor script. So first, down at the bottom, let's add a serialized property called action override property and action override string property. And these here are how they divide the script into sections like they did. So let's add a new one called customize UI. Now back at the top in the onEnable method, let's assign the properties we just created by finding those properties. What goes into the strings here are the variable names from our Rebind action UI script that we just set up. Okay, now go into our onInspector GUI function and let's add a customize UI section. And we can basically just copy the one from the UI section above, except let's replace this label here with our customize UI label and obviously swap our properties for the 2 that we created below. Okay, so now you can see they've been added. But honestly, I'd really only like this string field to show up if we've selected this bool here. So back in our editor script, let's get a reference to our Rebind action UI script and assign it as the target in onEnable. Now we can add an if statement in here. If our override action label is true, then we'll display the string field. Now you can see that's working in the inspector. Very cool. but this doesn't actually do anything yet. So in our Rebind Action UI script, we need to make a tiny change to the update action label function. Let's make it so that if our override action label is true, then we'll make the action label text to be equal to our string. And if not, then we'll throw in the action name if it's not null. And finally, let's delete our string whenever we make it false as well, so that it doesn't actually remember what we had written there before. Now, if we set this to true, we can call it whatever we like. And if not, it'll grab the name from the action map instead. Awesome. Next, I'm going to set up the gamepad canvas the same way we did with the keyboard. I'm not going to rebind the movement here because the analog and the D-pad are fine, and I'm not sure why you'd want to rebind those, but you can if you want. But for this, we're going to do icons instead of this ugly text. So Unity has actually already provided us with a handy little script for this as well. What you want to do is put it on the parent object of whatever is holding all your rebindings. So for me, I'm going to put this gamepad icons example script on my gamepad canvas here. So basically, this is going to check to see if you have icons assigned based on the control path. And if there are, it'll automatically turn off your text and turn on the icon. You could set this up for the keyboard as well if you want nice little icons instead of the text. You would just need to get your own icons and expand this functionality for all the keys on your keyboard. And if you don't know what the path names are called, you can click this little T here in the binding path and it'll show you the proper path. But now we just need to assign all the icons. I don't have a PS4 controller, so I'm just going to plug in the Xbox icons. They give you icons for both, which apparently are from opengameart.org, but they're all in this folder here. So let's assign them. You don't need to lock your inspector over here. You can just right click and hit properties and drag this over here and assign them that way. It's much easier. Okay, let's do this really fast. So if you try this now, it's going to give you an error. And that's because we need to add an image to our prefab. And it needs to be called this exactly. So let's add that in and disable it. Let's give it a width and a height of 24. Now it should be picking all those up automatically based on your control scheme. Awesome. Next, let's get that reset all button working. Create a script called reset device bindings. And I'm going to attach one to my gamepad canvas and one to my keyboard canvas. Now, if you have all your bindings on just one canvas, meaning you actually want one button to reset all of your binding overrides, then you could simply just create a function to remove all binding overrides. However, if you have yours separated like mine, we don't want the reset all button in the gamepad to reset the gamepad and the keyboard bindings, just the gamepad bindings, and vice versa. So let's create a string to hold the name of our device, and create a function called reset control scheme binding. So first we'll loop through each of our action maps. Then we'll loop through each of the actions within that action map. And we'll remove the binding override if the name of the binding group is equal to the string we set up here. Now it's important to distinguish the fact that we are not talking about the device within the binding path. We are talking about the control scheme group we manually set up in here. So the spellings from there need to match. Now let's fill in the controls here and type in our string for each binding group. And let's not forget to assign that method to our buttons on click event for both canvases. And now you can see I'll mess up the keyboard controls, and I'll mess up the gamepad controls. And now we'll hit reset all, and all the gamepad controls have been reset. But if we go back to the keyboard, you can see that it still kept the ones that we changed. Perfect. So this is all working except for the fact that we lose our rebindings as soon as we exit play mode, and that's no good. And again, Unity has actually already given us a good solution for this as well. They created this little script called rebind, save, and load. Let's attach one to our gamepad canvas and one to our keyboard canvas. Let's go ahead and assign the input action asset on both. You can see if we look inside, it's saving our data within a JSON file called in a string called bindings. When we disable this script, it saves, and when we enable this script, it loads. So you can see I'll mess up my keyboard and my gamepad, and we'll exit play mode. But if we go back in, it loads up all the stuff that we just set. Well, this one was a lot of work to put together, guys, so if you enjoyed or you got anything out of it, please hit the like button, share, comment, all that good stuff to help get this video shared with more people. Let me know if you have any ideas for improvements or anything like that so that we can all benefit from this tutorial as well. See you in the next one, guys. I want to give a very special thank you to our Hall of Fame patrons, Jakob Yondok, Zonder Kessler, Darren Perrine, Throbbing Wind, Fontaine Waite, and Couch, as well as our early access patrons, Zyoma and Ken Wade. If you choose to support us on Patreon, you can get early access to all our videos, monthly alpha builds, and more.